Imagine our planet, Earth, just drifting peacefully through the vast, silent ocean of space. Imagine our planet, Earth, just drifting peacefully through the vast, silent ocean of space. Now, picture something ahead. Not a distant star, not another galaxy. It's a black hole. This isn't some monster from a sci-fi movie. It's real. Utterly silent, completely invisible, and absolutely unstoppable. A region of space-time where gravity is so strong that nothing, not even light, can escape. We're on a collision course with the ultimate cosmic mystery. What would actually happen if Earth fell into one? As we get closer, you might be surprised. Initially, nothing looks wrong at all. From a distance, a black hole's gravity behaves just like any other massive object, like a star or a planet. The stars in the sky would look the same. The sun would still rise and set. Life would go on as normal. Black holes don't suck things in like a cosmic vacuum cleaner. They are more like a one-way street in space-time. You have to get incredibly close to be trapped. But there is a line, a point of no return. Scientists call it the event horizon. It's not a physical wall or a glowing gate. It's an invisible boundary. Once Earth crosses this line, there is no coming back. The escape velocity, the speed needed to pull away from the black hole's gravity, becomes greater than the speed of light. And since nothing in the universe can travel faster than light, our fate is sealed. We are now gravitationally bound to the singularity at its center. Long before we even reach the event horizon, the real trouble begins. The force of gravity starts to change dramatically across the planet. This is because the side of Earth closer to the black hole feels a much stronger gravitational pull than the side that is farther away. This difference in gravitational force is called a tidal force. At first, these forces would be subtle. We'd see massive, planet-wide tides. The oceans would surge and retreat in ways we've never witnessed, creating tsunamis of unimaginable scale. But soon, the effect would intensify. The solid ground beneath our feet would begin to feel the strain. The Earth itself would start to stretch. The planet begins to lose its familiar spherical shape. Mountains, which seemed so permanent and unyielding, would start to crumble and collapse under the immense stress. The Earth's crust would crack and fracture, triggering earthquakes and volcanic eruptions on a scale that would make our worst natural disasters look like tiny tremors. Our world is being pulled apart, piece by piece, by the relentless power of gravity. This process has a terrifyingly descriptive name: spaghettification. As we get closer to the black hole, the tidal forces become exponentially stronger. The stretching becomes more extreme. Earth is distorted from a sphere into an elongated oval, like a football. Then, it's pulled into a long, thin ribbon of matter. The planet's solid crust fractures completely. The molten mantle and the dense iron core are torn apart. Earth is no longer a planet. It's a glowing, superheated stream of debris, spiraling toward the black hole like water down a drain. Everything that ever was continents, oceans, life is atomized and stretched into a cosmic noodle. From the surface of this disintegrating world, the view would be utterly surreal. Space itself would appear to bend and warp. The light from distant stars would be distorted by the intense gravity, a phenomenon called gravitational lensing. Stars that should be behind the black hole would appear to surround it, their light bent into strange arcs and rings. The entire sky would look like a funhouse mirror. And then there's the effect on time. According to Einstein's theory of relativity, gravity can slow down time. Near a supermassive object like a black hole, this effect, known as time dilation, becomes extreme. For someone on Earth, falling in, time would seem to pass normally. But for an outside observer, far away, our clock would appear to slow down. Seconds for us would become hours, then years, then centuries for them. Reality itself is fracturing. As our stream of planetary debris finally reaches the event horizon, something strange happens, depending on your point of view. For that distant observer watching us, the image of Earth would appear to slow down more and more, getting redder and dimmer until it seems to freeze right at the edge of the black hole, frozen in time for all eternity, eventually fading from view. But for us, experiencing the fall, nothing special seems to happen as we cross the horizon. There's no wall to crash through, no explosion, no dramatic transition. We would simply pass from a region where escape was theoretically possible to one where it is not. The only noticeable change would be that the universe outside would disappear into an infinitely small point behind us, and ahead, there would be only darkness. Inside the event horizon, the laws of physics as we know them completely break down. Our journey continues toward the center, the singularity. Gravity here doesn't just get stronger, it grows infinitely powerful. Here, all the matter of the original star that created the black hole, and everything that has fallen in since, is crushed into a point of zero volume and infinite density. Inside the black hole, space and time are thought to swap roles. The dimension of space becomes time-like, meaning you can only move in one direction, forward, toward the singularity. And the dimension of time becomes space-like. It's a concept so bizarre it's almost impossible to visualize. The fundamental rules of the universe no longer apply. So, after all this, does Earth still exist? Not in any recognizable form. The planet, its atoms, and even the subatomic particles that make them up, are crushed out of existence. Some physicists believe that what remains is information. The information about every rock, every ocean, every living thing on Earth isn't destroyed, but it's encoded onto the surface of the event horizon, compressed beyond any form of matter we can comprehend. Earth becomes a whisper of data on the edge of a cosmic abyss. You might be wondering, why do scientists even study such a terrifying scenario? Because black holes are the ultimate cosmic laboratories. They push the limits of our understanding of the universe. By studying them, we test our theories of gravity, like Einstein's general relativity, under the most extreme conditions imaginable. They force us to confront the nature of space, time, and information. The quest to understand what happens inside a black hole is part of the search for a theory of everything, a single framework that can unite gravity with quantum mechanics. They aren't just cosmic destroyers, they are cosmic teachers. Now, you can relax. The good news is that Earth will almost certainly never fall into a black hole. The nearest one we know of is thousands of light-years away, and we are not on a path to collide with it. Our solar system is in a stable, quiet neighborhood of the Milky Way, but the universe is filled with these incredible, mind-bending objects, places where entire planets, stars, and even time itself can come to an end. The story of what would happen to Earth is a powerful reminder that space is not just beautiful and full of wonder. It's also incredibly powerful and unforgiving. It operates on a scale and by rules that dwarf our everyday experience. Thank you for joining me on this journey to the edge of reality. If you enjoyed this cosmic thought experiment, don't forget to like, subscribe, and hit that notification bell for more explorations into the mysteries of our universe.